Good morning. Today I want to talk about significant figures really quickly. Now, what is a significant figure? A significant figure tells you the number of digits that really matter in your answer. So, for example, like what does the number 20 actually mean? Well, actually, very little. Because as you know, there's a lot of different ways to get 20 with rounding. When you say 20, do you mean 19.8 actually? 19.9? 16? Did you round down? Is it actually 20.000? Is it 20.0012? Is it 22? So forth. So as you can imagine, because of this error and this issue, there's a lot of different interpretations that you might have for the number 20. Well, that's where significant figures comes in. You want to make sure your number is as exact and useful as possible, especially in chemistry where measurements matter so much. So how do we figure this out? Well, there happen to be 4 significant figure rules. The first rule is all non-zero numbers are significant. So if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, you know that all those count. So for example, there's 3, 4, 5, another 5, a 7, a 6, a 5. I see 7 different numbers here that count. This would have 7 sig figs. So this number is super exact, has a lot of precision. That's a good thing, a lot of accuracy. Zeros. Zeros are where things get weird, as you can see. So what backs up with zeros? Well, a 0 is where the rounding issue can come in. That's why there's 3 rules specifically set on zeros. If the 0 is in between numbers 1 through 9, they count. So for example, because these 3 zeros are in the middle of specifically this 3 and this 4, these numbers have accuracy. So essentially, we know that there is no hundredths, no thousandths, and no 10,000ths here. And we know that for a fact because there is a 3 sandwich and a 4 sandwich between them. So here, this would be 1, 2, 3, and these count 4, 5, 6, 7. This one is 8. Significant figures. Again, another pretty accurate. Now, we do not count. Zeros to the left of a significant figure do not count. So anytime you see a decimal, none of these count. None of these. And that is every single time, because they, again, are not significant to the left. So, for example, this one would only have 2 significant figures. Also, shout out those people who can handle my very poor mouse writing. I can do it with my finger, but it's not as good either, so sorry about that. Again, this works every time. Zeros to the right of non-zero digits, for example, 4,000 versus 4,000 decimal versus 4,000 decimal point. This is the weird one. These are significant if they are to the right of a decimal. So the decimal is the key thing here. So for example, there is no decimal here. These do not count. This is 1 sig fig. This number is not very accurate. Again, it's at 20. Also, 20 has 1 sig fig. Again, it can be rounded. We don't know if this 4,000 is 4,001, 4,499 you can round down. A lot of confusion there. This decimal point tells me that that is an accurate number. This would count. So this has 4 sig figs, and even after the decimal, again, because it's right there, these all count as well. So this would have 5 significant figures. That's my quick little description on sig figs. Again, big things, non-zeros count, zeros in the middles count, beginning zeros never count. Look for the decimal for trailing zeros. Have a great rest of your day.